Hi everyone, welcome back. Today we're going to look at MapReduce, the programming model of Hadoop. If you want to write a program that runs on Hadoop, that program needs to be written in a special way that follows a MapReduce model so that your program can leverage the scalability and fault tolerance that a Hadoop cluster can provide. First, let us understand MapReduce at a high level. Then we'll dig deeper into the details. At the high level, Hadoop scale-up computation using a master worker architecture, meaning a master computer coordinates many worker computers to work together to solve a computation problem using the MapReduce model. A simplified way to think about this is that there are two main stages. Stage 1 is to divide the data and its associated computation into smaller pieces so that each machine can work on one piece. After that, in stage 2, the results from all the machines are combined to produce the final results. Now let's describe this in more detail using technical terms from the MapReduce model. We now call our original divide stage the map phase. We will see shortly where the name map comes from. In this map phase, the work that is done is still conceptually the same, meaning data and computation are still divided into smaller pieces. But now we review that it's the master computer that decides on how this division is done, such as how big the pieces are. Also, we now give each worker a name. We call them mappers. Each mapper, as before, works on any pieces of data and computation that the master has assigned to it. The mappers work independently and in parallel. And for each piece of data and computation, a mapper will produce a corresponding intermediate result, meaning we will get many pieces of intermediate results from the map phase. Now recall that eventually we want to combine all these intermediate results into final results. So we need to move the intermediate results from the mapper workers to the workers that do the combination. We call this moving of intermediate results shuffling, because the intermediate results actually get moved from one machine to another across the network. But the good news is that this shuffling phase is automatically done for you. Now, after the shuffling, the intermediate results arrive at the right worker machines, and we call the workers that does the combination reducers. These reducer workers also work independently and in parallel. In this video, we learned about MapReduce at a high level. In the next video, we'll see an example MapReduce program.